These are solutions to exam 1 from 2017. So this is showing us plastic plates, so they're non-conductors. It's showing us the forces between some of them and to figure out the forces between C and D and B and D. So if I look at A and B, since they attract, that tells me that A, so if I just pick, let's see, if I just say, for example, like A is positive, then B must be negative. And then I look at A and C, and if A and C attract, since these two are the same, then B and C must be the same. So I must have B is also, or C is also negative in this example. And if A and D repel, then that must mean that D is also positive. Okay, so these are just examples. So if I know D and A are the same charge and C and B are the same charge, I can think about like this C and D. If C is negative and D is positive, then that means they're going to attract. And if B is negative, if D is positive and B is negative, then that means they're going to attract. So our answer is C. So C and D attract right here, and B and D attract right here. So our answer is going to be C. So let's go on to number 2. So we have two identical point charges exert a force of magnitude F on each other while separated by a distance R. Okay, so let's when separated by a distance R over 2, they exert on each other a force of magnitude, and we have to figure it out. Okay, so let's just write the equation for the force. So the force is equal to KQ, force equals KQ over R squared. And we'll call that F1. Right, so F2 is going to equal KQ. And now instead of R, I'm going to put R over 2. So I've just substituted, right? If the distance decreases, so it's half the distance, right? And I plug that new R in for this R over 2, and for that R, I'm going to get KQ over R squared times 1/4. Right, that's squared, so I'm going to get 4 KQ over R squared. And so this right here, KQ over R squared, is just F1. So that tells me that F2 is equal to 4 times F1. So 4 F1. So that means that my answer is A. Go. All right, next, so 3. We have two identical conducting spheres. Sphere A has a charge of 50 electrons, and sphere B has a charge of -10 electrons. So if the spheres then touch, the resulting charge on sphere A is, all right, so I'll just draw two spheres. They're equal. And this one, so those are the same size. This one's 50 E electrons, and this one's -10 electrons, and then they touch. So this is A and this is B. So once they touch, right, the charges balance out, so I get 50 E minus 10 E is equal to 40 E. And so since they're equal, we're going to have the same charge on each. So I'm going to divide that by 2, and I'm going to have 20 E. So it's going to be, the answer is C. 4. All right, so we have a charge of 4Q, at x equals 0, and a negative charge of -Q, x equals A, a third charge. So we're going to bring a third charge in with magnitude plus Q and locate it somewhere outside these so that it is in equilibrium. So that means, what this means, it is in equilibrium. That means that the force on Q3, so I'm going to have like another Q3, and that means that that's not going to move. When I put it here, there's not going to, the force on it from these two charges is going to be total, the net force from these two charges is going to equal to 0. And it's saying outside. So that tells me I'm going to put it either in this location or in this location. So I'm not going to put it in between because it's saying outside. So I'm going to think about the two possibilities. So if I put the charge here, so I'll call this zone 1. So if I have zone 1, and this we'll call this zone 2. So if I put my charge in zone 1, so I'm going to put, this is my Q3, my added charge, and my Q3 is plus Q. So I know, I don't know where it is, but I know that 4Q is located at 0, and negative Q is located at A. Okay, so thinking about this, if I think about, whenever I think about a force on a charge, so I'm thinking about what is the force on this charge that I've added? Well, I can think about, okay, this charge exerts a force on this Q, and it's going to point away, right? So this is a positive charge, this is a positive charge, so that means they're going to repel, and this charge is going to repel this charge. So it's going to repel pretty big too, because this is 4Q, right? So my equation for this is F is equal to K Q1, Q2 over R squared. So if this is my Q, say 1, and this is my Q2, this is 4 times that one. So a pretty big arrow to represent the force due to the 4Q on my charge that I've added. Well, what about this one? Right, this charge is going to attract this charge over here, but the distance between them is A plus whatever this distance is, and it's a smaller charge, so I'm going to have like a little arrow here, right? So this force due to negative Q, so we'll call this one force due to 4Q, and this is the force due to minus Q. And these two don't balance out. This is bigger than this one. So that means zone 2, or zone 1 is not an option. But what about zone 2? So in zone 2, so I've got, this is my 4Q, and this is my, and so that's at 0, and this is my Q, and that's at A. So I'm going to put my new charge right there. And so if I think about the force, so this is minus Q, right? So what's the force on this new charge due to 4Q? Well, remember I put the tail of my vector for the force and on the charge of interest. So I'm thinking that Q, is that going to move or not? If it's in equilibrium, it shouldn't move. So I'm going to see what the force is. So it's going to point away, but not as much as this one, this arrow, because it's farther away. So when I think about the distance, right, my distance here, it has to go through A plus whatever this distance is. Whereas here it was just going however far away it was. So this isn't as big. And then this one's going to point this way. Right? So I can place this at a location where these two arrows can equal. Right? And so since that's the case, then I'm going to pick zone 2. So great. So zone 2. So that means I'm not going to have A, and I'm not going to have, so that's it. Okay, so I can get rid of A, but at least it helps me to know to the right. Okay, so now what do I want to do is I want to make these two, put this charge in a spot where these two forces are equal. So let's write what that is. So the force here, this is due to the 4Q, that force is going to be F, call it 4Q, is equal to K, Q times 4Q over R squared. So that's this one. And then this F is going to equal K, Q times minus Q over R squared. Right? And so I want to set those two things equal. So I can say, so it's asking me what is the distance x. So K Q times 4Q. Oh, right, I forgot something here. So this R isn't quite right, so let's erase that. I have the distance wrong, right? These two r's are different. So r squared means the distance from 4q to this q. So we're going to call that a plus r, right? So this is the distance r. A plus r is the distance from 4q to q, and that's squared. And this one is r, so that's r from here to here. That's my r squared. So I'm going to have kq, 4q, over a plus r squared equals k, let me erase that for a sec. Nope, it's not letting me erase. Great. So say this is, I'm adding these two things together and setting them equal to 0. This one's negative, so q over r squared. Right, when I add them, if I pull that negative out front, that's where that negative comes from. I'm setting that equal to 0. And will this scroll for me? No. Okay, so I've got, I can factor out a kqq and a kqq. So now let's say I'm going to go up here and do the next part. So I'm going to say 4 over a plus r squared is equal to 1 over r squared. So then I can cross multiply, and I have a plus r squared is equal to 4r squared. And if I take the square root of both, I get a plus r is equal to 2r. So that means that a is equal to r, right? So I subtract minus r from both sides, so I get 2r minus r is equal to r. So I can put this charge, where am I? I can put my charge over here in zone 2, so I'm going to put it at a away. So I'm going to have a here and then a here, and that'll give me equal forces so that my charge doesn't move. So that means I'm going to, my x is going to be 2a. So if the distance from here to here is r, the distance from here to here is a plus a, which is 2a. So my answer is D. Let's see if I can make that D a little better. There we go. Okay, 5. Okay, so I've got 3 arrangements of charges, E for an electron, P for a proton, D for the distance. I think I'm going to stop here and I'll save this and then put this in the next video.